Hello. Welcome to this class of Persuasive Faith. I'm Rick Harvey, the teacher here in our local church. In this series of lessons, we are exploring the credibility of the Christian faith. If you find this lesson helpful, don't forget to hit the like button, and if you want to make sure you see future lessons, be sure to subscribe. If you would like a copy of the slide notes from this class, there's a link in the description below. Now, today's class. Last week we started talking about the existence of God, arguments for the existence of God. We're going to do the same today and next week. So all told, we'll talk about probably 7 or 8 different arguments for the existence of God. What is sometimes referred to as natural theology. That is, the things that we can know about God, the things we can know about God's existence apart from special revelation in Scripture. So the things we can know about God just through reason, through nature, and through things like that. So last week we talked just kind of generally about the arguments. We talked about inductive as opposed to deductive arguments, that most of the arguments for the existence of God are inductive rather than deductive, but there are some deductive, and we looked at a couple deductive arguments last week. So we looked at a rather sophisticated philosophical argument that has limited usefulness, not because it's not a good argument, but just because there are very few people who will follow it, which is the ontological argument. And then we looked at at really one of the most powerful arguments we have today, which is the cosmological argument. And we looked at one version of that called the Kalam cosmological argument that simply states, everything that begins to exist has a cause. The universe began to exist, therefore the universe had a cause. And then from that, we could ask ourselves, well, what would that cause be like? Given what the universe is like, what do we know about the cause? And we saw that we could infer from that argument, we could infer that the cause is immaterial, that he's timeless, that he's necessary, that he's omnipotent, that he's omniscient, and those sorts of things we can see from the inference from the cosmological argument. So today I want to talk just about one argument, and that is the teleological argument, and we're going to take all day on that. Some of the recommended resources. The first couple of them were on your list last week. Today, in addition, we have The Design Revolution by William Dembski. He's actually spoken here. We've had him speak here at Trinity several years ago. Darwin's Doubt by Stephen Meyer also has spoken here at Trinity. And then there is The Privileged Planet, which is available both in book form, in video form, and there's actually a talk along that lines available from the Dallas Conference on Science and Faith a couple of years ago by Jay Richards. So those are just some resources that are helpful to you. Most of them are fairly readable for the average person. Last week we talked about Anthony Flew, and I like to mention him again because he's a particularly good example of the effectiveness of the arguments that we're talking about last week and this week, particularly the cosmological argument, and the teleological argument that we're going to talk about today. He, of course, was very well known, very influential philosopher of the 20th century, very influential atheist. And then late in his life, he came to believe that God existed. And in his book, There Is a God, which was published in 2003, I believe, he says, "I have now been persuaded to present here what might be called my last will and testament. In brief, as the title says, I now believe there is a God." Okay? And he goes on to explain in that book how just the evidence, particularly the evidence from the cosmological information and evidence, and also from the teleological order of the universe, the argument from design, that these two things in particular led him to his new belief in God. I'm not saying that he ever became a Christian. I don't know that he became a Christian, but he certainly became a theist later in life. He says, I have followed the argument where it has led me, and it has led me to accept the existence of a self-existent, immutable, immaterial, omnipotent, and omniscient being. And so he really made quite a significant step in his perception about God, and this was in large part from the cosmological argument we talked about last week and the teleological argument that we're going to talk about today. So the teleological argument, sometimes referred to as the design argument, the teleological argument. The word teleological comes from the Greek word teleos. Okay, now does that ring a bell with you? Does that sound like something you've heard from the Bible? Actually, the word teleos is used several places in Scripture, but there's one place in particular that I'm sure you're familiar with, okay, in the Greek. Of course, you know, how many of us read Greek, right? And it so happens it is that time when Jesus is on the cross, right? He's on the cross, he reaches the end right before he dies, and he cries out, "It is finished," okay? The Greek word there is tetelestai. It comes from the root word teleos, okay? What is Jesus saying there? He's saying, I have finished what I came to do, right? I have accomplished something, right? So the word teleo in Greek just has that idea of finishing or of some purpose accomplished, some end in sight that is finally reached, like a goal, okay? So when we're using it in the sense we're using it today in reference to scientific issues, the word teleological refers to the fact that the cosmos at least appears, on the surface at least, to be arranged in such a particular and precise way as to permit life to exist. So, in other words, the universe is either designed or certainly appears to be designed for the existence of life. And the argument's been around for a long time. Starts with the Greeks, clear back with Plato and Aristotle and others, down through the medieval era. A number of the medieval philosophers and scholars would cite the argument or make the argument for the existence of God, up until you get to the Enlightenment. Okay, and then you get to the Enlightenment, and you encounter this Scottish philosopher by the name of David Hume, was a very famous skeptic, opponent of Christianity, and in his dialogues concerning natural religion, he sought to disprove the teleological argument, to demonstrate that it was false. That was actually published posthumously. And then about 25 years later, you get a Christian philosopher by the name of William Paley, but he is still arguing for the teleological evidence for the existence of God. And he's particularly famous for his watch on the heath analogy. So he describes a situation in which you're walking across a heath, a field, and you stumble across a watch, okay? And so you see this watch, you bend over, you pick it up, you look at it, and Paley's argument is, even if you had never seen a watch before, and even if you had no idea what the purpose of the watch was, you would know that that watch was designed, that there was something about the watch that just looking at it, you know it's designed. And his argument, of course, is that there are features of the universe, features of the cosmos, and features of the earth, and features even within biological life, that when you just look at them, they tell you they've been designed. Okay? So the strange thing is, though, that Hume's criticism of teleological argument, if you talk to atheists will oftentimes cite Hume and claim that Hume has defeated the teleological argument. All right? And the fascinating thing, though, is that Paley wrote 25 years after Hume, and he obviously is not swayed by Hume's argument. All right. So, and the fact is that the arguments that Paley makes 25 years later really are not susceptible to the kind of arguments that that Hume raised. And in fact, just a year after Hume's arguments were published in 1779, the philosopher Thomas Reid, who was actually more famous than Hume, wrote a refutation in which he really pretty much demolished Hume's argument. Stephen Meyer says Hume did not demolish design, Reid demolished Hume. Even though the argument, many people think that Hume has defeated the argument, in fact it is still quite strong and quite effective, as we saw with Anthony Flew. So about a little over 3 years ago, Mary and I had the opportunity to go to China for a couple of weeks to visit our daughter who'd been living there for several years. And we spent a couple of weeks in China, and for a little side trip, about 3 days, we took, this is down in southwest China, we took a trip to a very beautiful area called Tiger Leaping Gorge, and we stayed in a guest house run by a really fascinating Tibetan fella, actually, who owned and ran this guest house there on the sides of the gorge there at Tiger Leaping Gorge. And Christine had been there before, and so she took us for a walk that she'd been on before, and we walked up this road from the guest house, and we came across this. Okay, this is actually on the road to the guest house, and we came across that. And if you're walking through this beautiful rustic gorge and you come across this, the first thing that strikes you here is this is not natural, right? This is clearly something that people have designed and constructed. Now, it turns out there's a lot of bridges in the world like this. This particular bridge I found fascinating, and it has particular emotional attachment to me because I took this picture with my camera rather than my iPhone. And the reason I took the picture with my camera is because a few minutes before I dropped my iPhone off that bridge. Actually, I dropped it off this end, not down at the deepest part, and my daughter very courageously scrambled down through the rocks and recovered my smashed iPhone, okay? So I was able to get some data off of it. But at any rate, I'm very attached to this bridge. But right from about where this picture is taken, there's a little dirt road that takes off from the paved road and kind of goes up along the canyon. And we walked up this road maybe a quarter mile or so, and then I came across something else. I came across this. Okay, so we're right here by the stream now, where the stream comes up and comes right out of the mountain and waterfall. And I saw that, and I took that picture because I thought this illustrates this point that we're talking about here today, right? When I look at that picture of those three rocks, I'm absolutely as convinced that that was designed and constructed by a human being as I am of the first picture. Even though clearly one is much simpler than the other, and yet there's something about it that just cries out design, okay? So the question then would be, what is it about an object or a pattern or something that when we look at it, we go, that's designed? How do we detect design? And there's been some just fascinating work done on this. William Dembski, in his book, The Design Revolution, has done a lot of research in this area, and it's very fascinating. But the one thing that particularly stands out about a pattern or an object that we look at that tells us it's been designed by someone is something called specified complexity. Okay? And when we look at naturally occurring objects, so for now I'm just going to set aside biological things. So let's just talk for now about non-living things. We'll talk about biological things in a later lesson when we get to our science module. But just for right now, I'm just thinking about non-living things. And so if you look at it, non-living things in the natural world, they tend to have one of two characteristics. So the first characteristic would be specificity. So take, for example, a snowflake. A snowflake has a very, of course, they're all different, but they have a very striking pattern to them, right? You look at them and you see this very fascinating, this very beautiful pattern. They have a high degree of what we call specificity to them, all right? But they are not terribly complex. There's a little bit of complexity there, but primarily the thing that stands out to you is the specificity of them, okay? On the other hand, you come across the rock side and you don't typically think of specificity there. You don't think of a pattern, right? But you just think about the complexity of it. So you have all these rocks, and as it turns out, people who study probabilities and things like that, the probability that these rocks would fall and land in exactly this pattern, it's a very, very improbable event that they would all end up exactly like that, right? But clearly they did. And it's a very complex pattern, all right? But it's really not particularly specific. And so you encounter this a lot in nature. So, for example, you're looking at the clouds, and you see a cloud, and you say, oh, that cloud reminds me of George Washington, okay? So there may be a little specificity in there, but you know it's kind of accidental. What really strikes you about the clouds is their complexity, all right? So you'll get one or the other of those in dominance, all right? But let's say you're walking down the beach, all right? You're walking down a beach, and you encounter this, okay? And you go, wow, that was really an amazing sand artist that did that, right? Immediately you think design. And the reason you think design is because here you see both specificity, the image of a shark, and I don't know what that other stuff is. It looks like he's on a shipwreck or something. I don't know. Maybe this is from Jaws. I don't know. But there's a high degree of specificity, but there's also a very high degree of complexity. Millions and millions and millions of pieces of sand arranged in a specific way, in a very complex way, to evoke this image of a shark. And so what we learn from this is that when you have a high level of specificity coupled with a high level of complexity, we just automatically associate that with design. And we do that as adults, even small little children, even little babies will do that. They make that immediate association. Now, it doesn't mean it's an infallible association. We may be mistaken at times. Just last week I was watching on Ask This Old House, which I like to watch most weekends. They were doing a series of landscape fountains, okay? And so they were showing how to construct these fountains to look like they just naturally occurred, right? And so if you look at them from a distance and you don't see the pump and you don't see the rubber liner and all that sort of thing in them, if you don't see those things, you just look at them from a distance, you might think it was natural, but of course it's designed. So this is not an infallible tool, but it is a tool we all rely on every single day, many, many times a day, to evaluate something and say, well, that's naturally occurring, and this was designed by a mind of some kind. Even a bird's nest is designed in some way by a mind. So when we're talking about the teleological argument, then, we're talking about design, but primarily we're talking about, you can talk about two different aspects or two different approaches to the teleological argument. And the first would be the cosmological aspect, approaching it from the question of the universe, and specifically what we have in mind here is what's called fine-tuning, right? So So what we're talking about here is that within the cosmos, within the universe, we see this very exquisite, precise, remarkable fine-tuning of the universe and of the features of our own Earth, our own globe, that permit the existence of advanced life, and particularly of life, but particularly of higher forms or advanced life. Okay, so the universe is very finely tuned, we say, to support life. And so that's what we're talking about when we're talking about the cosmological part of our aspect of the teleological argument. And then there's the biological aspect, and this has to do with features within biological life. And a couple that we will talk about today as we have time are particularly what's called irreducible complexity in biological life, and the second thing is information. And these two things within biological life just cry out to us design. They just speak to us of design. So let's take a look at these two arguments. So first of all, what exactly do we mean by fine-tuning? Well, it turns out that with the way the universe is arranged, the way it's set up, the relationships of things within the universe, there are certain kind of numerical values and certain constants, and even the particular arrangement of various things that are set in such a precise way as to permit life to exist within the universe, or more specifically, life to exist on Earth. And what's striking about this is, of all these many, many different parameters and values and constants and things that exist, if any single one of those was just a little bit at variance from what it is, life would be impossible within the cosmos. Okay? So it turns out that when we think about if the universe just kind of came into being randomly, and all the way the universe is was just the result of some kind of random event, an explosion or whatever, if that's how it came into being, then it would be astronomically more likely that the universe would be life prohibiting than life permitting. So just given just a random arrangement of the universe, it's just virtually impossible that the universe could be life-sustaining. All right? And the thing about fine-tuning that's particularly helpful to us is it's not controversial. So any scientist in the related fields, cosmology, mathematics, physics, and those sorts of fields, will acknowledge the fine-tuning of the universe. Now, they'll differ as to how they explain it, if they attempt to explain it at all. Some don't attempt to explain it, and there are various explanations for it. We'll look at one here, the primary one here in a minute. But the fact of fine-tuning is not controversial. Scientists recognize that there are these many, many different constants and variables and arrangements and that sort of thing that permit for the existence of life. So it helps me to think of it this way, to think of a combination lock. Okay, so what you got is maybe a giant combination lock. Now you got this one here. You've only got 5 dials on it, and each dial has 10 possibilities, right, from 0 to 9. Okay, so you have a total of 100,000 possibilities of arrangements of those 5 dials. So there's only one number out of 100,000 that will open that lock. But imagine you have, instead of a lock with 5 dials on it, say you have a lock with just scores of dials on it, okay? And the dials aren't typically, they're not 0 to 9, but they're, dials have anywhere from hundreds to thousands of numbers on them, okay? And each dial is different, all right? Then clearly the possibilities of opening the lock get more and more impossible. So each time you go up a dial, Each time you add a variable, right, you multiply by that number. You don't add. So if you just had one dial, you'd be 1 chance out of 10. But as soon as you have 2 dials with 10 numbers, then it's not 20 possibilities, but 100 possibilities, right? 10 times 10. And so the point is, each time you add a variable, the number is multiplied by that number of possibilities. So take, for example, here, Newton's law of gravity. So Newton's law of gravity is mathematically stated is F equals G times M1 times M2 divided by R2. Pardon?
R squared, not R2.
R squared, yes, R squared, yes. So if you just reading that out, that's G, which is what's called the gravitational constant, times the mass of the first object times the mass of the first object times the mass of the second object divided by the distance between the two objects. Okay, and that's how you get the quantity of the gravitational force. All right. And what's striking about this is this gravitational constant G has apparently no constraint on it. There's nothing that determines what G should be. So when the universe came into existence, what made the gravitational constant what it is? And scientists have no idea. There's no explanation for what makes G precisely what it is. But if the value of G, this gravitational constant, were just slightly at variance from what it actually is, a life-sustaining universe would be impossible. In fact, in large measure, the universe itself, as we know it, would be impossible. Either the universe, instead of expanding at the rate it's expanding, would have expanded so rapidly, everything would have just spread apart and dissipated, and you wouldn't have had planets or anything like that. Or if it had gone the other way, and the gravitational force had been stronger, the whole universe would have just collapsed in on itself shortly after its beginning. So the value of G is very important, but it has to be in a particular range, a very finely tuned range. So it turns out that, like the gravitational constant, scientists now have discovered around 200 different values or things like this that had to be just exactly right in order for there to be a life-sustaining universe and a life-sustaining planet. And I gave you a handout there. We don't have time to go over all of those, but you have a handout there with some of them, and I've listed some of them here on the next couple slides. I've got the gravitational constant up there. The particular mass of the Earth had to be just exactly right, or you couldn't have life. The actual our moon is a particularly large moon relative to the Earth. It needed to be about that size in order to sustain life on the Earth. The size of our star, the type of star that we have, things like the ratio of water to land on the Earth is crucial for the existence of life. Our climate, why is our climate range, roughly between 0 degrees and 100 degrees Fahrenheit, so it's fairly livable, instead of being clear to one extreme or the other. The very initial conditions at the very beginning of the universe, okay, what scientists refer to as the Big Bang. The initial conditions, including the law of gravity, had to be set within what is called Planck time, which is the very shortest period of time possible. It's a minuscule fraction of a second, okay? And within that first Planck time, within that first minuscule of a second, you had to have a number of the parameters for the universe in place if the universe was eventually going to be able to sustain life. The relationship between what are called the four forces, the gravitational force, the electromagnetic force, and the strong nuclear force and the weak nuclear force, Each one of those numbers had to be exactly right, and the ratio between them had to be exactly right in order to support life. So each one of these values then has to be set within this relatively precise parameter. And if you have, and like I said, there's like 200 of them, but if any one of those is out of sync, then you can't have life in the universe. So every time scientists discover a new one of these parameters, every time they discover one, the improbability of life existing on Earth grows exponentially. Okay, like I say, you don't add to it, you multiply it. So it grows exponentially, right? So the point that I'm making then is that the probability that we would have a universe, if it just happened by just random occurrence, the probability that we would have a universe that's life supporting is so immense that it's as close to impossible as anything could possibly be. Okay, it's just remarkably stunning that we have a universe that is that precisely tuned, and that just cries out to us of design. So my little picture over here of the three rocks stand, you know, I could give you an explanation of how that happened. You know, naturally these rocks fell down off, you know, and they rolled across the little valley floor there and bounced up and balanced. You know, I could give you a natural explanation of that, and you would look at me like I'm crazy, right? And so that's what we're confronting here on just a much more massive scale. So how then do scientists seek to explain, or what are the possible explanations for this kind of fine-tuning? And there are three reasonable possibilities, or three possibilities. And the first is necessity. They just had to be this way. The universe just popped into existence out of nothing, or whatever, as we said, some argue last week. It just popped into existence, and these things, they just, by some law or something, they just all had to be the way they are. Okay, but scientists don't know of anything that would dictate that kind of necessity for all of these things being what they are. And so the second possibility is chance. And the idea here is that the chance of us having a universe that has all of these parameters just exactly right is just so impossibly small if you only have one universe. But what if you had a bunch of universes? What if you had what would be essentially an infinite number of universes? If you had an infinite number of universes, then it becomes not only probable but certain that one of those universes would have all these features, because you'd have an infinite number of possibilities, right? Or nearly infinite number of possibilities. So this is what is referred to, you often hear it called the multiverse. So there are many scientists who propose that the solution to this problem, because they don't want to believe in a designer, the solution to this problem is a multiverse. Okay? There are several problems with the multiverse hypothesis, though. One is there's just no evidence to support it. We don't have any evidence. We have a lot of theories, but there is no evidence of a multiverse. More troubling than that is you can't get evidence of a multiverse. All right? Because each one of these universes is outside of our universe, and according to the theory, operates under different laws than our universe. So there's no way that we, looking from our universe, could ever see a multiverse or see another universe and be able to detect it because we are constrained by our universe. Mathematicians, on the other hand, have argued and demonstrated, some of the world's leading physicists have demonstrated that it's very, very unlikely that a multiverse actually exists. But even if you allow for the possibility of a multiverse, okay, I'll give you the multiverse. You can have your multiverse. There's a problem. And the problem is that in order for the probabilities to work out, in order for all of these universes together, combined together, creating the probability of this universe existing the way it is, all those universes have to emanate from one source. They all have to emanate from some kind of universe-generating mechanism. And in order for a universe-generating mechanism to generate a universe like ours, it has to be finely tuned. So the multiverse doesn't get you past fine-tuning, it just moves it back several generations back. Okay? So that's the problem with that argument. So the third possibility then, of course, is design. And it just seems like an intelligent mind is just the simplest, easiest way to explain and the most comprehensible way and comprehensive way for us to explain this remarkable fine-tuning of the universe. But Richard Dawkins objects. And Richard Dawkins says, well, wait a minute. In order to propose a God that designed the universe, if the universe is complex, whatever designed it and created it has to be more complex than the universe. And his argument, he relies upon Occam's razor. We talked about Occam's razor a couple weeks ago or so. Occam's razor is that the simplest explanation, everything else being equal, the simplest explanation is the preferred explanation. So his argument is that a fine-tuned universe just exploding in and of itself is a simpler explanation than God, because God has to be more complex. But once again, as he often does, he's mixing categories. Because when we're talking about the universe, we're talking about a material thing. God is not matter. God is spirit. Okay? So most Christian theologians view God not as being complex, made up of parts, okay, but they view him as simple, as spirit. Okay? His ideas certainly are complex, that's another issue, but he himself is simple. So when we're proposing God as the solution to the fine-tuning question, we're not proposing something that's more complex than the universe, we're actually proposing something that's much simpler than the universe, because God is not made up of parts. We'll look at that idea more later when we get to our study on the nature of God. So this whole issue then of the fine-tuning of the universe is referred to as the anthropic principle. So if somebody's talking about the anthropic principle, they're talking about this idea of the universe being designed in this very fine-tuned way, or existing in this very fine-tuned way to allow for life. And typically, when people talked about the anthropic principle, that's all they were referring to. Okay, they were just referring to this aspect of the universe. But using a little sleight of hand, the skeptics like Richard Dawkins and other atheists have changed the use of the term anthropic principle. And they've changed it simply to refer to the fact that we observe a finely tuned universe. So it's no longer the fact of the finely tuned universe, but to them the anthropic principle is that's the kind of universe we observe. Okay, and that seems like a very small point, but it actually becomes very important, because what they're really trying to do here is they're trying to sidestep the improbability problem. They're trying to basically say, well, it's not so improbable after all. Okay, and this is how they do it. So they take the question as it is, okay, and they change it to say, well, of course we observe that our universe is life permitting. It has to be life permitting, or we wouldn't be around to observe it, right? So, because we're living beings. So if I'm here, any universe that I'm in has to be a life-supporting universe. So they change the question so it's no longer highly improbable, but rather it's highly probable that a life-permitting universe is observed. So, as I say, the argument attempts to sidestep the problem of the overwhelming odds against the life-permitting universe by suggesting our universe was necessarily life-permitting, or we wouldn't be around to view it or to see it. So, what's happening here? Well, actually, what they're doing is they're committing the fallacy of equivocation. We've talked about the fallacy of equivocation a couple weeks ago or so. Okay? So they're taking the question as it should be stated. They're taking it from, what are the odds that a life-permitting universe would exist at all? And of course, the answer to that is, it's just impossibly small, as we've seen. Okay? So that's the question, and that's the right answer. But they have changed the question to, what are the odds that a living being would observe a life-permitting universe? What's the answer to that question? What are the odds that I, as a living being, would observe a life-permitting universe? It's certain, right? It's you know, and by that sleight of hand, by that equivocation, they've erased the probability problem, right? Well, I like what William Lane Craig does with their argument. He uses the firing squad illustration, okay? And so he says, so you take a firing squad of, say, 20 expert marksmen, okay? And the guy yells fire, you know, the commander yells fire, and they all fire their weapons. And lo and behold, the guy standing against the wall is still alive, okay? Well, the relevant question at that point is, why, well, it's not, to start with, the question is not, why does he standing there observe that these 20 marksmen missed him? Okay, that's not really the question. The question is, why did the 20 guys miss him? All right? The question after the fact is, why, given the odds against failure, did 20 marksmen fail to kill him? That's the question that has to be answered. If the guy's still standing there alive, of course he's going to see that they failed to kill him. Okay? That's certain. What isn't certain, and what does beg for explanation, is how did 20 marksmen fail to kill the guy? All right? So on our level then, the appropriate question from the anthropic principle is not, why do living things observe a life-supporting universe, but why does such a universe exist given the astonishing improbabilities against it? So don't let their little sleight of hand throw you off on that. Okay, so that's the cosmological aspect of the teleological argument. And then there's the biological part of it. And there are a couple parts here to this argument, at least a couple, and one is what's called irreducible complexity. So one of the things that stands out to us, of course, about biological life is just how incredibly complex it is. Right? It's just, whether you're looking at even just a one-cell organism, or you know, or whether you're looking at a human being or a human eye or a heart, or you're looking at a tree or whatever it is you're looking at, if you look at it closely, you begin to see just how just incredibly complex it is. Okay? And there are many features within biological life. There are just 2 or 3 that tend to get referred to over and over again. But there are literally thousands upon thousands upon thousands, and probably millions of different features or elements within biological life that we say are irreducibly complex. All right? So what do we mean by that? Well, Michael Behe likes to give the illustration of a mousetrap. So you have a mousetrap, and a mousetrap has several different parts to it. All right, so it's got the wooden base to it, it's got the little catch thing you put the cheese on, it's got that spring, it's got what's called the hammer, which if you've ever let a mousetrap slam you on the finger, it feels quite a bit like a hammer, right? It's got that little hold down bar, it's got actually 4 different staples in various locations on it. And Michael Behe says this is irreducibly complex. And what he means by that is if you reduce it by any single part, it cannot function for its purpose. Right? So in order for it to function as its purpose, it has to have all of those parts, and all those parts have to be assembled together in the right order, but within a very short period of time, or it simply does not function. Okay? And what he says is that's analogous to many things in biological life. And so there are many things in our bodies, there are many things in other elements of life, other living things, that are actually made up of numerous individual parts, all of which have to be in place at the same time for it to function. All right? We'll explore some of this later because there are some arguments against this, but we'll explore those later when we get into our science module. Okay? And so each part has no other biological function apart from its function within the whole of that particular item. And he gives the example of the bacterial flagellum, a very famous example, but there are many others, okay? And in the case of the bacterial flagellum, you have this little propeller on some bacteria, okay? This is how they get around, all right? And this propeller looks very simple on the surface, you know, it's just propeller stick, but it turns out it's incredibly complex and has 40 different parts to it. All right? And if you take away any one of those parts, you take away the stator, you take away the rotors, you take away the bearings, you take away the propeller itself, you take away the U-joint, you take away any one of those parts, it no longer serves a function. And under the dictates of Darwinian philosophy, it would be discarded. Okay? So you couldn't assemble this with, you know, part of it now and then another part 200,000 years from now and another part another 100,000 years from now and another part 50,000 years later, because under the dictates of survival of the fittest, it would be a wasted part and it would be discarded. And so this is one example of what's called irreducible complexity. This cries out to us design. It cries out to us design because the whole idea, the purpose of something that serves as a mobility tool for the bacteria, that purpose is in mind, and then a designer appears to have designed it with all these various parts so that it could function in the remarkable way it does, and I don't even have time to explain that, but to function in the remarkable way it does so that this bacterium could live. All right? And without it, the bacteria, of course, would die. So, irreducible complexity points to teleology, that many aspects of biological life give evidence of having been designed with a purpose by an intelligent mind. And then the second aspect in biological life, and we'll come back to this time and again over the next number of weeks, is this issue of information. So, biological life is just jam-packed full of information. Okay? So some of you have a Bible sitting there on your lap. The Bible is just full of information. But the information is not the Bible. The information is not the printed page. It's not the letters on the page. It's not the ink. Okay? The information is transmitted by those material things, but the information itself is immaterial. It's not matter. It's not energy, okay? And yet we have all of this information, and typically what most people think of when they think of the information in biological things, they think of DNA, okay? And DNA, okay, is of course the classic example. So you have the DNA structure that I'm sure you're familiar with, and those little steps in the ladder, so to speak, each step is made up of 2 of 4 possible what are called bases, A, T, G, and C, right? And it turns out that the information in DNA is not in those bases. The information in DNA is in the arrangement of those bases. Just like the information in Shakespeare is not in the letters, but it's in the arrangement of the letters and the words and the sentences. Okay? So again, the information is not matter, it's not the bases. It is, in fact, the way those bases are arranged within the structure of DNA. Well, it turns out, though, that scientists have discovered that there's a lot of stuff going on in the cell that is not governed or determined by the DNA. In other words, there's other information in the cell that doesn't originate from the DNA, and they call this epigenetic information, above or beyond the gene. Okay? So we have a bunch of information in DNA, but we also have this other information we don't even know for sure where it comes from, that's in the cell, that's telling the cell what to do. And there's just simply no materialistic explanation for this, right? And the fact that there's information in biological life and in the cell, nobody disputes that. Everybody recognizes that. But here's the problem. We know of absolutely no case where information just arises spontaneously from material causes. We only know of one source of information, and that's the mind. Okay. And when I use the word mind, we'll talk about this in a few weeks when we get into the nature of humanness. When I'm using the word mind, I'm speaking of something distinct from the brain. Okay? I'm talking about the immaterial consciousness. All right? And it's from that immaterial aspect of our existence that we know information arises. We don't know of any other source of information. And so clearly the existence of information in biological life is pointing to a mind of some kind. We don't know of any other explanation or any other source. So the teleological problem, in spite of David Hume's best attempts to try to refute it, still remains as one of the strongest arguments we have outside of Scripture itself for the existence of God. And as I pointed out, it was this just kind of unrelenting evidence from the teleological argument as well as the cosmological argument that ultimately led to Anthony Fleur's change of mind regarding the existence of the deity. So next week we'll go on, and next week we're going to kind of pack in a bunch. We're going to talk about a number of different arguments, so we obviously won't go into them in the detail that we have last couple lessons, but so that's where we're headed next week. So any questions or anything?